Hello everybody, and welcome to part 3 of a 3-part series on H bridges. And we know that an H bridge will allow a microcontroller to change the polarity of an external voltage source to a motor and change its direction. In this presentation we'll discuss a particular module and we'll discuss some of its specifications. Now remember, our H bridge is a circuit that can reverse the polarity to a DC motor. So if we look at this, S1 and S4 are closed while 2 and 3 are open. The one side of the battery is connected, or the motor is connected to VCC, the other side is connected to ground. And if we close 2 and 3 and open 1 and 4, we'll reverse that polarity and change the direction of the motor. What we're going to talk about on this presentation is the L298n H Bridge. The L298n motor driver can control 2 DC motors simultaneously, up to 2 amps each, and we can also control the speed using pulse width modulation and also its rotational direction of the motors. So in our setup, we've disconnected these bridges right here. We've taken those out, and that's motor enable A and motor enable B. We're going to use pulse width modulation on those control signals. These control signals is N1 and N2 for motor A, N3 and N4 for motor B. And our actuators will be connected, one actuator will be connected here, and the other actuator will be connected here. We're going to connect a 12-volt supply here. We're not using the 5-volt connection. We're just using the 12-volt in the ground. And don't forget we're using an external 12-volt supply. We're going to connect the ground of that to the ground of the Arduino. We're using 2 actuators, 2 linear actuators with 50 millimeter stroke. Remember, the stroke is the extension of this rod, how far to go out, and 50 millimeters, around 2 inches. The speed is 10 millimeters per second. It's a 12-volt supply that we use. The force of this will surprise you. It's a 900 Newton load capacity, which is around 200 pounds. And it's 25% duty cycle. We're also, on this one, we're using a joystick. And we have the left-right connection to A0, the analog pin of the microcontroller, and A1 is the up and down one. And then this is a common ground, and either one of these we can use. However, for both of these we need to use VCC to both connections. One's for the left-right, because this is 2 potentiometers internal. One's for the left and right side, one's for the up and down side. Here's our schematic. And we're using digital pins 4, 5, 6, and 7 for our control signals. For N1, 2, 3, and 4, we're going to be providing 5 volts and ground on those pins. And then our pulse width modulation is going to come through on pins 9 and 10 on enable A and B. And this is our L298N motor driver. We're going to control 2 actuators. And we have a 12-volt supply going into our motor driver. We have a joystick here, and we're connecting to our analog pins to read that, just like reading in our values from a potentiometer that we've done in the lab. And here's our Arduino Uno we're using with a 9-volt supply. And don't forget to have a common ground between the power supplies. Let's review some of the code. The analog inputs will read a value of 0 to 1023, corresponding from 0 to 5 volts. And the joystick is actually 2 potentiometers together, so we're using 5 volts to ground to feed those potentiometers to the analog pins. So about half of 1023 is 512, and that's approximately the center position of the joystick. Then we start to convert that declining value of 512 to 0. So if it's less than 512, so 512 to 0, we're going to convert that to 0 to 255, increasingly amount of pulse width modulation number. And that'll affect the speed. So when we use the, when enable A and B are high, then we're using pins N1, N2, N3, and N4 with the polarity shown here. So if we have N1 high and pin low, pin 2 low, and pin N3 high and N4 low, this allows one direction of both of those actuators. And if we reverse those, like we do here, we reverse these polarities, then we're reversing the direction. So this one here says we're going forward, and the other one says we're going backward. And then we map these values. We mapped it here too as well. That's the way our code works. This is looking at our setup. Here's our L298N. Here's our microcontroller. We're powering with a 9-volt supply. We have an external 12-volt supply all plugged into here. Didn't show your actuators, but I will have another video where I show the demonstration of using those actuators. Thank you and have a good day.